The title of my project is Content-Based Document Retrieval. It's a system that retrieves the most relevant documents from the query with the help of combination of TF-IDF, which is a statistical method, and BERT, which uses semantic meaning. I built this with the help of Python, Sklearn, and Hugging Face. The main goal is to measure the TF-IDF speed with word context understanding. The need for this retrieval system is nowadays there nowadays there is a massive amount of digital text such as research papers, articles, and reports. Traditional keywords such as like TF, IDF work well for simple queries, but they don't understand the actual meaning of the sentence. So I decided to combine TF, IDF, and VERT, a transformer-based model from Google, to make a hybrid retrieval system that is both fast and smart. With digital text expressions, smarter such tools are needed. So what I think is TF-IDF works on frequency but lacks meaning, whereas word understanding semantic context. Understanding BERT embedding. BERT reads text bidirectionally to grasp the context or the meaning, converts the sentence into dense vector embedding. By embedding it, it allows semantic similar comparison. Example, if the user query is health food benefits, it finds the nutrition or the diet documents which are relevant in our documents. The overall workflow of the system is at first I imported the required libraries like pandas, pods, sklearn, and other transformers, and then I extracted the dataset, which is a zip file, and read all the text documents from it. And then next, I built TF-IDF embedding, which represents how important each word in each document. After that, I loaded BERT model, which converts each sentence into meaningful numeric vector. And then finally, I wrote a search function that compresses the query with all documents using both TF, IDF, and BERT, then combines their scores to show the best search results. And finally, now let's go through the code and understand it. At first, my system uses TF-IDF, which stands for Term Frequency and Universe Document Frequency. It is a method that checks how often a word appears in a document compared to all other documents. If the word appears many times in one file but not in others, it becomes an important keyword. So TF-IDF helps the system find documents that share important words with the search query. It's very fast but only works on exact words. It doesn't understand any meaning. The second part of the code uses BERT, a powerful AI model that understands meaning and context. But this text both on the right and left. That's called bidirectional understanding. Instead of counting words, it converts the whole sentence into numerics called embedding, which captures the actual meaning of the text. So even if the query words are different, Bird can still find the related documents from our dataset. So to get best results, I combined both methods, TF, IDF, which gives quick keyword matches, and BERT, which gives deep meaning matching. I gave 70% here. I gave 70% importance to the word and 30% to IDF. That balance makes the search both accurate and fast. So here I use it formula 0.7 into word plus 0.3 into TF IDF. So the finally what happens is the user types a query in the search bar. The system converts the query into both TF and IDF and word vector, then compares them with every document using cosine similarity. It is a mathematical way to see which documents are more similar to the query, and the top results are ranked and shown with small snippets. Here I am going to show you with an example. Here we search the then it will show us the most relevant documents based on our search query, like the first document here. The first document which gives the same meanings as our query. So in this way, my context-based document retrieval system, which is a hybrid model that uses both statistical and deep learning technique, but to improve search events. It's also efficient, meaningful, can be used in academic, care, or legal document retrieval. Thank you.